So in this video I'm going to look at the November 2014 paper. It's the higher paper and it's a non-calculator one. Keep an eye on the formulae because you'll be looking at those later on and referring to them. So let's have a go. Let's start the paper then. So in this question you're given some information, basically that 6.7 times 52 is 348.4, and you have to work out the values of these. Well, let's have a look in a little bit more detail. Let's start with the first one. So what would 6.7 times 520, what would that be? Well, if you compare it to the original question, then you can note that the 6.7 has remained exactly the same, but the 52 has become 10 times bigger. So the answer itself will be 10 times bigger. And 348.4, lots of 10, is just 3,484. So try and compare it every time to the original that you were given. So let's have a look at the second one. If I write the original here, there we go, and we want to do 67 times 0.52. Well, first of all, we know that 6.7 has actually got 10 times bigger, so we know it would be 348.4 times 10. But then the 52 has actually got smaller. So 52 divided by 10 would be 5.2, and then 5.2 divided by 10 again would be 0.52. So we'd actually have to divide by 10 and then divide by 10 again, because we did that twice. So what would the answer be? Well, if we times something by 10 and then divide by 10, think times by 10 and then divide by 10, we're actually doing nothing to it, we're just timesing it by 1. So these are as good as cancelled out. So all we're left with is 348.4 divided by 10, which must be 34.84, and that should be the answer. Right, let's have a look at the last one. I'll put this over here. So with the last one we have 3,484 divided by 5.2. So let's give ourselves a little bit more room. So first of all I would write down 6.7 times 52 is 348.4, and I would divide both sides by 52, and that would give me 6.7 is the same as 348.4 divided by 52, but I want here 3,484 divided by 5.2. That's the same as in fractional form. So the first thing to do would be to try and get 3,484 on one of the sides. So if I times this side by 10, I've got to do the same to this side. So that would give me 6.7 times 10, which is 67. And then, of course, when I times a fraction by 10, I'm timesing its numerator only, the number. So I'll have 3,484 divided by 52. And then here's the tricky part. I've got to somehow make this 52 into a 5.2. So what I have to do is, if I call this 67 over 1, this is my way of doing it, I would divide this denominator by 10 to make it 5.2, then I'd have to do the same to this one. Now, I think you'll understand this. If you have 67 divided by 1/10, our 1/10 is 0.1, and then we have 3,484 here, and 52 divided by 10 is 5.2, so we definitely have what we wanted here. So all we've now got to work out is what is this, And if you don't know how many 0.1s go into 67, then what you can do is you can just times the top one by 10 and times the bottom part by 10, which is really the same as timesing by 1, and you'll get 670 over 1. So the answer should be 670. So don't be worried about the explanation. There's plenty of ways of doing this question, but basically you've just got to try and rearrange it and try and fix the numerator and denominators to be what you needed, and then what you're left with on the left hand side will be the answer. Okay, so let's move on to the next question. So what's the next question? Well, it's a QWC question, quality of written communication. And it says Karen got 32 out of 80 in a maths test. She got 38% in an English test. So for the maths, here. For the English, she got 38%. Karen wants to know if she got a higher percentage in maths or in English. Did Karen get a higher percentage in maths or in English? Well, one way of looking at this is 32 out of 80. You can halve the top and halve the bottom. You can then halve the top again and halve the bottom. Carry on doing this until you get something recognisable like 4 out of 10. Now 4 out of 10, you can then times the top by 10 and the bottom by 10, and you get 40 out of 100. And every time you see something out of 100, it's per 100 or per cent, because cent is the shortening for 100. So this is definitely 40 out of 100 or 40%. So it looks as though Karen did better in her maths. Another way of looking at the question, so I don't just want to go through all these questions, I want to try and show you different ways of doing them if I can. Let's have a look at this one a different way. Is this 32 divided by 8 times 10? Well, you can see straight away that 8 into 32 is 4, and then you can see the 4 out of 10 really quickly, which leads you on to 40% really quickly. So that's another way. And one final way would be to say that if 100% would have been 80 out of 80, then 10% would have been 8 out of 80, 20% would have been 16, and 40% would have been 32, which is what you wanted. There are many other ways of doing it, but there's 3 ways for you anyway. So in this question we've got to draw an ordered stem and leaf diagram. So let's have a look. So we've got the stems sorted out, we've just got to put the leaves in. What I tend to do is do one here so I can quickly tick them off. So I've got an 84, an 88, an 89, and then I can order those 4, 8, 9. Then I'll do the 9s, so I've got 98, 90, 91, 91 again, 97, 93, a 90, a 95, and a 92. And then I order these. So I've got 2 zeros going on, 2 1s, a 2, a 3, and then 5, 7, 8. Now I can finish off the rest now, so I've got the 10s, and that will be 10 with a 2, 10 with an 8, 10 with a 3, a 10 with a 6, and then 2, 3, 6, 8. And then lastly the 11s, I've got a 0 and a 5. So I'm looking to see if there's anything about a key. I've course, this is where you'd put your answer in here. And I'm just seeing if there's anywhere there is a key. No, there isn't, but I'm going to draw one anyway. So I would just say that 10 2 would equal 102, for example, and just put key here, just in case you'd lose a mark for that. Okay, so that's simple enough. That's an ordered stem and leaf diagram. So for this question, if you were to buy X packs of currant buns and there were 6 in each pack, then what kind of expression would you have there? Because the way I think about it is, if you've got X packs and each pack has 6 in it, then wouldn't 6X be reasonable for the amount of currant buns you had? Because if X was 1 pack, you just have 6 times 1 currant buns, which is 6. And if X was 2, you'd have 6 times 2, which would be 12 currant buns, and so on. So don't be writing things like X6, because that doesn't make any sense in maths whatsoever. Don't write X to the power of 6, because that means X times itself 6 times in a row. You want to write 6X, because that is saying that there's 6 currant buns for every pack. Okay, so that's the first one. And then this should be easy now, because if you've got Y boxes of ice buns and there's 8 in each box, then you want to be adding 8Y, and that's the total. So I would say T equals 6X plus 8Y. It doesn't matter if you write 8Y plus 6X, that's absolutely fine as well. So let's have a look at the next one. It says solve the inequality 6y plus 5 is always greater than 8. Well, with inequalities, like I've said before, the only thing you can't do with inequalities is times by a negative number both sides, because then you're going to change the inequality sign. There's also dangers when you square root, but you probably won't see that on your GCSE at all. So in this situation, if you have 6y plus 5 is greater than 8, would it be allowable to take away 5 from both sides? Well, you're not timesing by a negative here, so if you just took 5 off both sides, then you should be fine with 6y is greater than 3. And then if you divide both sides by 6, 6 being a positive number, then you're not going to change the inequality sign, and you're going to be left with y is greater than 3/6, which is the same as y is greater than 1/2. And if you were to draw that on a number line, you would mark off 1/2 here, and then you would put a hollow circle, because then you can't actually be the half. If you had greater than or equal to a half, then it could be the value half, and you would just shade that in. But we don't have that. We have y is greater than a half. In this question, we've got x here. I think the way of best explaining this is to look at the end points and say to yourself, can x be less than 4? Yes, it seems like that's okay to start with. It can be less than 4. Can it be equal to 4? Yes, it can be. So it seems to be able to be less than equal to 4. Then look at this extreme here and say to yourself, well, I've got -3. Can x be equal to -3? No, because it's a hollow dot. But can x be more than -3? Yes, it can. So you've got to somehow get all these put in together, because although x is greater than -3, it can't be 6, for example, which is greater than -3, because its bound is 4, so it can't go over that bound. So somehow you've got to write a sentence in maths which links both of these together. And here's the way of doing it. You put your end points here, so you've got -3 on one side, you've got 4 on the other, put your x in the middle, and then you've got to somehow read a sentence all the way from here to here, and then separately here to here, and it's got to make sense. Now I would start from here to here first, and you just read your first sentence, x is less than or equal to 4. Okay, that's true. So from there to there, that reads true. Now you've got to read it from here to here, like you would a sentence. And you've got to say something that makes sense to this diagram. So negative 3 is something x. Well, if you tried negative 3 is greater than x, would that be true? Think about it. Negative 3 is greater than x would mean x is less than negative 3. So I'll say that again. If negative 3 is greater than x, and I'll draw a big negative 3 here and a little x, so negative 3 is bigger than it, that would mean that x is less than negative 3. But x isn't less than negative 3, because it's not allowed to be there. So then you change your mind and say, well, let's try this sign here. Negative 3 is less than x, so negative 3 is less than x. That would mean that x is greater than negative 3, and that's what you had here. So the way to combine these is to do them separately and then write a sentence, so when you read your sentence from here into x and then from x to here, they both make sense at the same time. That's the best way I can explain this. Of course, some of you can just see this straight away, because this can be less than or equal to it, and then you can see this straight away, and then you can just write your answer down. But I wonder if you had to explain it to someone, whether you'd be able to really explain. That's as best I can do on that, but like I said, any comments would be really good. So let's have a look at another question. So, quality of written communication again, so be careful about your workings. Steve wants to put a hedge along one side of his garden. He needs to buy 27 plants for the hedge. Each plant costs £5.54. Steve has 150 quid to spend. Does he have enough money? Well, it looks as though you've got to somehow do this multiplication first. So I would do 554 times 27. So I'll do that first. Of course, you'll have your own ways of multiplication. So I'd have 43, 45, 45, 49. So I'd have 14958. Then I'd use my estimation, and I would say that was 27 times 5 roughly, which is 135. So I know the answer is going to be roughly 100 and something. So I'm going for £149.58, and that would have to be true. Of course, you've got your own ways of doing this. Some of you can put decimals in your multiplication. However you do it, don't lose sight of estimation. Even if you said 30 times 5, you'd get 150, which is really, really close to this anyway. Okay, so as long as you've got the digits, £149.58, that's really good. And then you've got to see whether he has enough money, and he has £150 to spend. So yes, he's got 42 pence spare, so you'd say yes, has enough. Okay, next question. The diagram shows the plan of a floor. The area of the floor is 138 metre squares. Work out the value of x. Well, let's have a look at this one. I think what I'd do is I'd probably split this off here, and I'd have 3 here, and this is 8 still. So I'd have 8 metres times 15 would be all of this, and 8 times 15, that's 120 metres squares. And then for this one, this is a bit tricky. If it's all x to here, then what's this distance here? Well, it surely must be 15 with the x taken off. So this must be 15 minus x. So the area would be 3 multiplied by 15 minus x, because you do length times width. So we need to add those two together. So we've got 3 lots of 15 minus x plus the 120 we got before, and that's got to be the total, which is 138. And then basically we can solve those to get 45 minus 3x plus 120 equals 138. And then we just need to solve for x. So we've got 45 and 120 is 165 minus 3x is 138. I would add 3x to both sides, and I'd get 165 equals 3x plus 138. Take the 138 from both sides, and then it looks as though I'm left with 27 equals 3x, divide by 3, and so x equals 9, and that will be 9 metres. I think I've seen another way of doing it while I was doing that, and here's another way. I would probably say 15 times 11, because all of this is 11 here, would be too much. So 15 times 11 is 165 metres squares, and then I'm just going to take away 3x from it, because that was the bit that was too much. So 165 minus 3x would be the whole area that I wanted, and that gets me down to this part immediately. So that's definitely one way of looking at it, and then you just carry on as normal from here. So that would lead you to the answer of x equals 9 metres. I'm sure there's other ways of doing it. You could split it in different ways, but there's two ways anyway. Let's have a look at the next one. Again, QWC. You're given all the information here. You've got to work out the angle marked x. Give your reasons. Well, I think the first thing I would say is alternate. So alternate angles. So this would be 65. So I would say angle BFG equals 65 because alternate angles, and I use this angle here for angles. So that's the first thing to note. Then also triangle FBG is isosceles because it's marked as given. So therefore we know that angle FBG is 65 because the base angles of an isosceles triangle. I think that would be enough. And so we know that this is 65 also. And then I would personally use alternate angles again. So I'd have alternate, 3 syllables, 3 strokes of the pen. So alternate angles. And then I'd say x is 130. So I would say x equals 130 because of alternate angles. I can write that as this again. You could add a little bit more and say ABG is equal to BGH and write alternate angles. Sometimes your brain's working faster than you can actually write, and I can see why a lot of my students in the past, as well as present students, find it hard to write down all their workings because you kind of know what you're trying to say, but it's just actually putting it down in words. So you've explained it, fully, and some people get a bit impatient and tend to just rush to the next question. I'm very guilty of that as well. So hopefully that's enough workings to get the marks on that question. I'm sure if it's not, people will tell me. So let's have a look at the next one. Jack wants to find out how far people live from their nearest supermarket. He uses the question on a questionnaire. Not my favourite type of question, to be honest, but let's try and pick 2 things wrong with this question. I think the first thing is it said how far, but there are no units of length. So 0 to 2 what? 0 to 2 paces, 0 to 2 feet, miles, inches, it's not really said very clearly there. So there's no units of length given. And secondly, this is the real big no-no. If you wanted to answer 2, say 2 miles, then you could tick this box and this one at the same time. So you would say there are overlaps. So this would be ambiguous. You don't have to use that word, but just say there's overlaps and there shouldn't be. So let's have a look at the next part. Jack also wants to find out how often people go shopping. Write a question Jack could use on his questionnaire to find out how often people go shopping. So really what you've got to do is just ask the simple question, and that is, how often do you go shopping? And let's say a week. And then just give some responses. Make sure they don't overlap. So you could say 0 to 1 times, 2 to 3, 4 to 5, and then I think, to be honest, that's probably too much, and then I would just say 6 or more. Okay, so that's a very simple question. You're not leading the person, and you're just giving them some responses, and there's going to be no ambiguity, i.e. no confusion. Right, use ruler and compasses, both of which I don't have at hand, not on this computer package anyway, to construct the perpendicular from point C to the line AB. You must show all your construction lines. Well, I can give it a good go. I think by just looking, I'd put my sharp point here of my compass. So I'll put my sharp point here, and then I would extend the compass out so it just touched this line. Okay, so, and I would basically swing it out so I'd make some kind of mark here so it touched the line and went through it. And then I'd keep the compass exactly the same distance and swing it out to here. And then from these points, I would keep the compass exactly the same distance apart, and I'd put my sharp point here, and then do another part of a circle here, an arc. Then I would change my sharp point to be here, and so on. And then basically I'd link this point up to where these two crossed. So I'm about to make a mistake on this because I'm drawing it by hand. And that would be at 90 degrees for sure. So I'll go through that again. Sharp point here. Extend your compass out. And then just don't change the distance between the pencil and the sharp edge, the sharp point. And then just go from here, sharp point to arc, sharp point to arc, and then join these up. And that's a good way of doing that every single time. So have we done it? Use ruler and compasses to construct the perpendicular from point C to the line AB. You must show all your construction lines. Yeah, it's really important that you really overemphasize these parts here. Okay, and then put this in for good measure. Okay, next one. Ria is going to buy a caravan. The total cost of the caravan is £7,000 plus VAT at 20%. Ria pays a deposit of £3,000. She pays the rest of the total cost in 6 equal monthly payments. Work out the amount of each monthly payment. Well, first of all, let's work out 7,000 with VAT added on at 20%. So there are numerous ways. You could times this by 1.2, which would add the 20% straight on as the multiplier. And if you know what 7 12s are, which is 84, then logic should tell you that would be 8,400. Okay. Another way is to say that if you have 10%, that would be 700 of this amount. and then 20% would be 1400, and if you had the VAT added on, then you'd have to add this 1400 on to the principal amount, which is 700, and then you can see again you've got your £8,400. I think without a calculator it's, maybe I'm making it look too easy because I find numbers reasonably easy. It's probably not so easy to do this. I'm just trying to think of another way. Well, say you'd said 7 times 1.2. Well, 7 twelfths. This is like question 1 really that we had on this paper. If 7 twelfths is 84, then 7 times 1.2 must be 10 times less. So you get 7 times 1.2 and then try and build it up to 7,000. So 70 times 1.2 would be 10 times bigger, back to 84. 700 lots would be 840, and then 7,000 lots would be 8,400. So there's a few more ideas, but it's 8,400. And then if £3,000 deposit is paid, then you've got 8,400 with 3,000 deposit paid. That's 5,400 to pay in 6 equal monthly payments. So you've got £5,400 to pay, and then you've got 6 equal parts. So you've got 5,400 divided by 6. If you halve the top, that's 2,700, and halve the bottom, that's 3. And then think, does 3 go into 27? Yes, it does. 9 lots, 900. So that should be enough to show that you know what you're doing. So you've found the 8,400, you've taken off the deposit. That leaves you 5,400 to pay, and you've got 6 equal payments. And if you want to do a long division sum, that's absolutely fine, because you can go 6 into 54 is 900. Okay, so that wasn't too bad. Now we want to factorise this here, and I went over some factorisation in the last paper I did. So I would personally write all this out as timeses, and then circle the things that are common. So I have an E here and an E here. So I take out the E and I'm left with 3E plus 5. And then in your head just multiply it out. E times 3E is 3E squared, and E times positive 5 is 5E. So we'd have E lots of 3E plus 5. Then we want to solve this one, so I would times out the brackets. So 7k minus 21 equals 3k minus 5. Be careful, we're not doing 7 minus 3, which is 4. If we have 7 lots of k minus 3, it's 7 times. So we've got to multiply everything in here by 7. That's the k and the minus 3. Then I would say from here, take 3k from both sides. And that would give you 4k minus 21 equals negative 5. So you've got your k's there. So I'd add 21 to both sides, and then you'd end up with 4k equals 16, and then divide by 4, and you would have k is 4. Now let's have a look at this one here. I always say there's no shame in doing a grid. So 2x, 3x minus 8. You can put the plus sign here if it helps. So let's multiply these out. 2x squared, 3x, minus 16x, and then a minus times a plus, then minus 24. So we'd have 2x squared minus 16 and 3x, or 3x take away 16x is minus 13x, and then minus 24. Now it wouldn't matter whether you put minus 24 first, then added the 2x squared, and then did minus 13x. I think what the examiner wouldn't like is if you wrote 2x squared minus 16x plus 3x minus 24, you'd lose one of those marks because you've not simplified this enough. So let's have a look at part D. I think for this one, you don't want this denominator of 4 to be here, so I'll definitely times both sides by 4, and I'll have 7 minus 3f equals 8. I think a common mistake here with this question would be to add 3f to both sides. Well, it's not 3f because it's all being divided by 4, so it's actually 3 minus 3/4 f, so be very careful there. So I then from here would probably either go in two different ways now. I think the first way is I'd times both sides by -1, and I'd have -7 plus 3f equals -8. Then I'd add 7 to both sides, and that would give me 3f equals -1, divide by 3, and so f would be minus 1/3, or from here I could add 3f to both sides, and I'd have 7 equals 3f plus 8, then take away 8 from both sides, and that would give me -1 equals 3f, and then divide by 3, and I'd have -1/3 equals f. You don't have to decimalize this and say -0.33 and do this, because that would be wrong, and that's where some people lose a mark. You'd have to say f was -0.3 recurring with a bar or with a dot, but I personally would steer very clear of trying to decimalize with equations. So that's those ones done. Express 180 as a product of its prime factors. Well, a way that I like doing this is to say to my students, just try and write anything. So 18 times 10, is that good enough? Yes, it is. And then just break those numbers down. So 10 is 2 times 5. Are they both prime numbers? Yes, they are. So that's done. And then 18, just break it down to the first that comes to mind. 6 times 3. Is 3 prime? Yes. So these are all nice and prime. And then the 6 is just 2 times 3. So you've broken it down into its prime factors. Let's do this another way, just in case that worried you. So 180, you could say 60 times 3. 60 is 20 times 3 times the 3. And then 20 is 5 times 4 times 3 times the 3. And then it's the 4 that's annoying here, but that's just 2 times 2. So there's another way. There's many ways of doing this. I'm not a fan of the factor tree. It's okay, but I think it's I can't even remember exactly how it goes. I think it goes something like this, yeah, and so on. I don't really like it because I like to try and work it out a bit faster. Some of you might just like these methods. That's absolutely fine. Then use them and you've got no problem. Where here I then try and neaten it up a little bit. I start with the smaller ones first, and then 3 times 3, and then the 5. Sometimes students write 2 squared times 3 squared times 5. I'm sure that would be okay as well, but I'd probably leave it like that for GCSE. Now let's have a look at the next part. Martin thinks of two numbers. He says the highest common factor of my two numbers is 6, and the lowest common multiple of my two numbers is a multiple of 15. Write down two possible numbers that Martin is thinking of. So I think the best way of finishing this question off is to think that we need to have the highest common factor of my two numbers is 6. So they've got to have 6 as a common factor, at least. And it's got to be the highest common factor, i.e. the highest number that will go into both of them. And the lowest common multiple of my two numbers has got to be a multiple of 15. So let's have a look. Well, if we look at multiples of 15 down the side here, and so on, let's start with just two numbers. Let's say we thought the answer was 3 and 5. Well, first of all, could that be correct? No, because the highest common factor of my two numbers has got to be 6. So 6 has got to be the highest number that goes into both. So 6 doesn't go into 3 and 6 doesn't go into 5. So try and think of something with 6 in it at least, because 6 will go into 6. And then say you think 12 is the next one. Well, let's try 6 and 12. So does this obey the first rule? Is 6 the highest number that goes into both of those numbers? Well, the highest common factor of 6 and 12, 6 is 6 times 1, 12 is 6 times 2, so yes, it is. But is the lowest common multiple of my two numbers, is that a multiple of 15? Well, if you did the 6 times table, and then the 12 times table, and so on, do you get them to be the same? So let's look at the lowest common multiple here, 24, and that is not in the 15 times table. So you have a think first. What two would you start with? Well, I think I'd go with something like 6, and I don't think I'd try 18 next. I might go with 30. Let's have a look at those two. Now, first of all, if we look at the highest common factor, so 6 times 1 is 6, and 30 is 6 times 5, so 6 is the highest number that goes into both of them, so that's good. And if we do the 6 times table, 6, 12, 18, 24, 30, 36, 42, 48, and so on, and the 30 times table, 30, 60, 90, 120, 150, then they've got nothing in common yet until, let's have a look, 6, no, I can see one here, 30. Now, that's the lowest common multiple, so that would mean that the lowest common multiple would be a multiple of 15 because it's in the 15 times table. And that's why I didn't choose 18, because if I did the 6 times table down here, and then the 18 times table, 18, 36, 54 and so on, I'd see they both had 18 in common, but 18 would not be in the 15 times table. That's why I went for 6 and 30. And now I can see that you could have 12 and 30 as well, because does it obey by rule 1? Well, you've got 6 times 2 here and 6 times 5, so 6 is the highest common factor. And if you did the 12 times table, and then the 30 times table, can you see that 60 is the lowest common multiple? And that is in the 15 times table. So there's two pairs. I think the ones I would go for is 6 and 30, but you could probably have 12 and 30 and a whole lot more as well. But there's two for you. So for this question, you've got to work out how many millilitres of wallpaper remover should Suha use. Well, it says here that the information it gives you is that for every 600 mils of wallpaper remover, you've got to mix a quarter of the wallpaper remover with 4,500 mils of water. Now, when I look at this question, I can see that if you have 4,500 mils of water, you've got to mix a quarter of 600. Now, a half of 600 is 300, and so a quarter is half of that again, which is 150 mils. So that's water here, and then wallpaper remover is going to be 150 mils. So that I think is going to help me a great deal now, because I've basically got to have 750 mils of water, so I've got to somehow make this into 750, and whatever's left here will be the answer. I think the first thing I would do to both sides is divide by 10, and that would give me 450 mils of water for every 15 mils of wallpaper remover. Then I think that I would divide both sides by 5, and that would give me 90 mils of water, would give me 3 mils of wallpaper remover. So I'm just going to write in what I did there in case you lose track. So I divided by 10 here, then I divided by 5 here. So I've got 90 mils here. Then I think what I'm going to do is I'm going to divide both sides by 3. So that's going to give me 30 mils of water is 1 mil of wallpaper remover. And then I think I'm just about done, because I know now that if I times both sides by 25, I'll have 3 25s are 75, but I had 30 lots of 25, so it's 750. So 750 mils of water would give me 25 mils of wallpaper remover. Now, I'm just thinking to myself, some of you would worry at that. So let's have a look at another way. So let's do water here and wallpaper remover. Let's say 4,500, because I'm conscious that we don't have a calculator, okay? So we've got to think really carefully here. So we've got our 150 mils that we started with. Now I'm just trying to think, is there another way of doing this? I guess what you could do is say that 1 mil of water is 150 mils divided by 4,500. So that might seem a bit scary, but if you just try and cancel out here, divide by 10, and then divide by 5, gives you 3, divide by 5 is 90. Can you see that's exactly what you've done here? And then you can say 3/90 is 1/30. And then if you say that's 1 mil, if you then times both sides by 750, you would get 750 mils would be 750 30ths of a mil there. And then can you see divide by 10, and then 75 over 3 is 25 as you wanted. So that's 2 ways of doing it. I'm sure there are plenty of others, but either way you've just got to try and get 4,500 here to appear as 750, but you've got to do exactly the same, and you can use the idea of ratio wherever you wish. That's absolutely fine, but as long as you obey the rules of ratio, you'll be absolutely fine as well. So I think whichever way you want to do it, it's completely up to you, but there's 2 ways for you. So let's have a look at this. We've got to draw a box and whisker plot for the information shown in the table above. So we know the least is 60 minutes, so make sure we can check our scale here. So 50, 60, 70, 80, 90, 100. So we've got 60 here, so there we go. You can put that in, that's done. We know the range is 230, so if the range is 230, does that not mean that the distance between the least and the greatest is 230? So surely the maximum point here, or the most amount of time, or the greatest would be 230 add 60, which would be 290. So 50, 60, 70, 80, 90 here. So that's done. The median is at 170. So there it is, the median, which is the second quartile. The lower quartile is the first quartile, or the first 25%, which is here. And the upper quartile is the third quartile. So we have the first quartile, the second quartile, which is the median, the third quartile, which is the upper quartile, which is 220. And then the interquartile range, inter means between, like intercity is between cities, like a train goes in between cities. So interquartile is between the two quartiles. So this is where you draw your box, which shows you 50% of the data, because it cuts out all of it, and it just gives you a chance to look at the 50% of the data. So there's your box here, and these are like your whiskers. Okay, so you have the least, the greatest, the lower quartile, the upper quartile, the median, and this data here represents the interquartile range, which is 50% of your data. So what is it asking next? It says, the box plot below shows information about the amount of time the boys spent doing homework last week. So compare the amount of time the girls spent doing homework with the amount of time the boys spent. So let's have a look. So the first one is all about the girls here to start with here, and this then is about the boys. And it says compare, so that's quality of written communication again, so we've got to think carefully about that. So to get the marks, which is 2 marks here, always look at how many marks are on offer. You really should talk about the spread, which is like 50% of the data, so we can do that first. So if we look at the spread here, we can see the girls have a greater spread. So if we look at the spread here, so the spread for girls is, well, how much is that? It's from 100, so we look at here, between 100 and 220 is 120 minutes. For boys, it's between 110, so it's between 120 and 210. 210, that's 220. So that's 100. So you can say the girls have a greater spread in terms of minutes doing, I think it's homework, a week. And then another good thing is to compare one of the averages, so in this case the median. So what can we say about the median? So for the girls, the median was 160. Minutes. For boys, it was 190, I believe. So from that, you can then say that the girls had a lower, sorry for writing over this, a lower median than the boys in terms of minutes spent per week doing homework. Now, that's obviously gone a lot more than the lines as allowed, so you're probably getting an idea that I would probably write too much in the exam, but I'd rather write a bit too much than not enough, that's for sure. So you've compared the interquartile range, the spread, and you've compared a median, which is always a very good thing to do. So that will get you the 2 marks. Well, this question is going to be quite difficult because I've got to draw it on a grid on another page. So I'm going to have to just explain to you that when you draw a cumulative frequency curve, which is called an ogive, spelt like so, then you plot the end point here versus the cumulative frequency. So it's always the end point. You always go as far as you can on the interval. Okay, so I'll try and plot that now, and then we can have a look at this part here. So we've got to say 10% of the workers at the factory are older than 65. Okay, so you might just want to have this paper with you. So 10% of the workers at the factory are older than 65. That's how we've got to think about it. So I'm just going to plot that now. So let's plot that information. So the first one here was 20 versus 25. So 2, 4, 6, 8, 10. So it's there, 25. And then we had 30, 70. 40, 138. 50, 175. 60, 186. 70, 194. And then 80, 200. Now, what I normally do is this. I would definitely turn the page here. So let's have a look. And I would try and draw the ogive nice and carefully. So let's have a look. So under the arc, like so, and then turn the page this way. You can say here that 0, 0 would be a point. If there's no age, there's nobody going to be counted as 0 age. So we can come through here. So let's have a look. Like so. And then somehow we've got to join these up here. This is a bit harder, but you can give it a try. Just practice a few times and you'll be fine. So that's okay. I'm not saying I've done that brilliantly, but it's not as easy to do this on a computer program like this. So that will do for now. So that's the ogive done, and the question said 10% of the workers at the factory are older than 65. That's what Graham said. He said that 10% of the workers at the factory are older than 65, while there was 200 people working at the factory. So that was the information that we're given on the other page. There were 200 workers, and Graham said that 10% of them are older than 65. So all we have to do is look at 65 along here, and then we draw a dotted line all the way up, which mine's not going to be amazingly accurate here, but it'll be fine. So we go to 65, and then read along here. So that means greater than 65 in terms of age would correspond to only 10 workers, okay? because this is the cumulative frequency, it's the frequency so far. So in the first interval we had up to the age of 20, the second interval was all the way up to 30 and so on. So we only have 10 workers which would be 65 or above, but, well, Graham's wrong then, because he said 10% of the workers at the factory are older than 65, when really he should have said there's only 10 of the workers, and 10 out of the 200 is 1/20th, okay, or 5%. So he was wrong, not correct. Okay, so that's that question done. I think for this question here, we've got to try and find the size of the angle KFE. So there we have it there. We've got to find that angle. And I'm just trying to think, because I try not to plan these questions too much. Let's have a look. How would I do it? I think I would join these two up here. And then this is an isosceles triangle. And then this angle here would be the same as this angle here. Now we know we've already got 140 taken from the triangle. So from triangle, we'll call it KFC. Sounds funnier than FCK. So KFC would be add up to 180, so that's 180 degrees. And we've already got 40 of it taken off, 140 of it taken off. So that would mean that these two dotted angles would be 40 together. So one of them would be 20. Now once we've got one of those as 20, I'm just trying to think now what I would actually do. Well, I know that if I had the centre of the octagon here, this angle would be 45 degrees, and I know that this exterior angle is always the same as the centre angle. So by that token I would know that this here on this straight line was also 45. Well, this angle here has got to be 90 altogether, so I'll just draw that as a right angle there. So if I already have 45 degrees of it taken up and then another 20 degrees taken up, that is 65 degrees, and that only leaves 25 degrees for what I need. So I would say angle KFE is 25 degrees. But I'm pretty much sure there's many other ways of doing this question. But I think it's pretty much to do with exterior angles all the time. And as you've got an octagon, you're starting from one position, you're turning until you get back to the start. So you're turning 8 times at 45 degrees to get back to the whole turn. But I think if you know the connection between the centre angle of a regular polygon and its exterior angle, the relationship being that they're the same, I think that would be a great help here. So we're going with 25 degrees. Well, in this question it says that ABCD here, ABCD, which is a trapezium, and AEFG, which is a trapezium also, are mathematically similar. So I've explained that in my previous video, which was the June 2014, about similarity. So what that means is one is a scale factor enlargement of the other. So we have to look at corresponding sides here. Now I can see that this length here would correspond to this length here. And we're given the dimensions here as 12 and 18. So we can say that 12 in the smaller one is times by something to give 18 in the larger one. So if we divide both sides by 12 here, we'll end up with x, which is the scale factor of enlargement, is 18 divided by 12. Well, 18 is 3 times 6 and 12 is 2 times 6. So we get the scale factor of enlargement is 3 over 2 or 1.5. So we'll write that down. Okay, and we've got to work out the length of AB now. So if you think about it, and one thing I do say to my students sometimes, it's useful to do this. Sometimes you can draw two diagrams like so, and you can have them kind of like next to each other. So I think I might have to just move that one a little bit. I might do it down here. So if you kind of just draw the diagrams here, that's the smaller one, and then you've got the larger one here. Then if you think that you know this one here, 5, and you want to find this one here, I won't call it x because I've already used x, I'll call this y, then you know what the scale factor of enlargement is. So you know that you can find AB because it's going to be 5 times the scale factor that you found, which is just 15 over 2 or 7.5 centimetres. So sometimes it's useful to draw the shape outside of the main shape and then compare it with the bigger one right next to it, okay? And then you can look at the corresponding sides here, okay, like I did in this case. It says the trapezium AEFG has an area of 36 centimetre squares. Work out the area of the shaded region. Well, that's not quite so easy. So before we look at this one, let's just have a little look at something here. So let's have a look at scale factors in terms of length, area and volume. Now we found out a length scale factor of 3/2 or 1.5. If we then wanted to find out the area scale factor from this, given the length, we would have to square it because area is in units squared. It's made up of the lengths times lengths to give areas. And so you'd have 3 over 2 all squared, which would be 9/4. So the area scale factor would be 9/4 between the smaller and the larger one. If you had to look at volume, in this case we're not asked about volume, but if you are asked to use volume and you know the length, then if you think of a cube, like so, cubes are made up of length times width times height, so they're made up of 3 dimensions, so you're having to not only times the length by itself once, but by itself again. So you'd have 3 over 2 times 3 over 2 times 3 over 2, which is 3 over 2 cubed, which gives you 27/8. So let's go back to this question and see whether we can use that to help us. So let's have a look. It said here that AEFG, which is the smaller one, had an area of 36 centimetre squares. We have to work out the area of the shaded region. Well, let's not worry about that too much. Let's just work out what the area of the larger shape would be. So we knew that its scale factor for length was 3 over 2, so its scale factor for area is 9/4. And if you wanted to do that in decimals, then you'd have 1.5 all squared, which is 2.25. Okay, if you prefer to work in decimals. I prefer fractions, so we'd have 36 times 9/4, and 4s into 36 is 9, and I'd end up with 9 nines, which is 81 centimetre squares. So the area of all of this is 81, but we want the shaded part. So if we do 81, which is the area of this part, minus the smaller one, that will leave us with the grey part, or the shaded area. So the answer is going to be 81 minus the 36, which is going to give us 45 centimetre squares. Okay, so not an easy one there. So I just want to go back to this a little bit here if I can. If we look at what I've written here, if, for example, another little mini lesson here, if you had scale factor and you were given, say, the area one was 4, a scale factor of 4 with the area, how would you work out the length and the volume? Well, my advice is always go back to the length. So to get back to the length, you'd have to square root 4, which would be a scale factor of 2, and then go to the volume, which is 2 cubed, which is 8. So my advice is, whichever one of these you're given, always try and get back to the length and then work up to the other one. So you may see some questions, well, you're going to see some questions if you do enough past papers, but you're not always given the scale factor of the length. Sometimes you're given a scale factor of the area and you're asked to find out the volume, and that's probably the hardest one. So keep your eye on that, and let's do another question. So for this question, we want to try and complete the table of values for this hyperbolic graph here. Now, as x gets bigger, y will get smaller. Just try and think of it as 4 cakes and x amount of people. The more people that turn up, the less of a cake you're going to have. So y is going to be 4 over x, and that's going to have not a straight line shape to it. So we're going to plot the points afterwards and we'll see what shape it has later on. But let's have a look at some of the points here. We're given that x is 4 here. So if we have 4 divided by 4, then that's going to be 1 whole one. If we have 5 here, then that's going to be 4 divided by 5. And don't forget, when you come to plot this, 4 divided by 5 might be a little bit more difficult. So you might want to say that's 8 divided by 10, or 0.8. And then, because don't forget you've got some decimals here, so that's probably giving you a bit of a hint that decimals may help you with this scale. And then you've got 8, so 4 divided by 8 is 0.5. Then you've got x is a half, and that's where they're trying to trick you to make, well, not that they're trying to make you make a mistake, but it's more likely that you will make a mistake if you don't understand what's going on here. So 4 divided by 0.5, always, if you see a decimal, try and double out of trouble. So if you double the top and double the bottom, you get 8 whole ones. So now we're ready to try and plot these points at least, and let's hope that what we did was going to help us. So let's have a look. Let's start with this one. 1 along, 4 up. There we go, that's easy done. 2, 2. There's another one. 4, 1. Now 5, 0.8. That's why this decimals is easier to do than plotting 4/5. Unless you know a fifth of the whole one is 4 bars up, that's fine. So I'm going to go 0.8, so 0.2, 0.4, 0.6. Well, there's 0.8 there. And then 8.5, well, that's going to be halfway. So you've got to be careful with this one. That's there. I'll enlarge that a little bit so you can see. And then we've got this last one to do, half along, 8 up. So half along, that's here, and 8 up, that's here. Okay, now in a previous video I've said that if you've got a series of dots like so and you want to draw an arc, turn your paper this way and always draw underneath the arc, or underneath the rainbow, as I tell my younger students. So go underneath the arc and start joining these up, and then it should be easier for you to do. You could take your pen off there, turn your page a little more if it helps, and then complete this. You can take your pen off there again and then move the page, and then finish it off. So that would be a good way of starting. I think for this question, I wouldn't try and go too much further than the points that I'd plotted, just in case you get it wrong. So just stick with this range here. And it does say draw the graph, and there's an inequality again. Remember that inequality question we had? Let's read it through. X is less than or equal to 8, so it can be the 8. There's 0.5 here waiting for us, and look, it can be that, so there. So look, there we go. X is between 0.5 and 8, and it can be both of them. So when you're plotting this, don't try and go up here, even though you've got a sense it will go up this way, and this one will go this way. I wouldn't necessarily plot those, because you may make an error. Okay, so just stick to the bounds. That's what it's called, the bounds of what the question is asking. So let's have a look at the next one. So in this question, you've got a solid shape. It's made from a cylinder and a hemisphere. Well, here's the cylindrical part here. And do a better one than that. And then here's the hemisphere. A hemisphere is half of a sphere. And basically, you've got to work out the total surface area of the solid shape. Give your answer in terms of pi. Right, so let's have a look. Well, the first thing is to probably have a look at the formula sheet on the front of the paper, and that does tell you the surface area of a sphere. And I try and tell my students that basically you can wrap 4 circles area around a solid sphere. So the surface area of a sphere is 4 of the area of a circle, 4 pi r squared. So the curved surface of the very top is going to be half of that. So we've definitely got this part, this curved surface part here, which I can do in 2 different colours. That curved surface part here is going to be 2 pi r squared for sure. So we can just write that down as curved surface of sphere. When I say sphere, we know that's a hemisphere. And then we've got to look at the rest of the diagram. Now, if you think about this, we definitely have a circle at the bottom here, and we should have some information here. It says the cylinder has a height of 10 and the curved surface area of the hemisphere is 32 pi. Work out the total surface area of the solid shape. Give your answer in terms of pi. Well, you may be wondering, and I'll do this in another colour, you may be wondering what this distance is from here to here. Now we know the radius of the hemisphere is the same as the radius of the cylinder because it tells us that. So I think what you have to do in this case is look very carefully at this part here. Now, what we already had was, we have the curved surface area of the sphere was 2 pi r squared, and we're told that the area of the hemisphere was 32 pi. So if we divide both sides by pi, we'll get 2r squared equals 32, and if we then halve both sides, we will get r squared equals 16, and that means r would have to be plus or minus 4, but we're talking about a radius of a shape that exists, so r would be 4 centimetres in this case. So really, all we've got to do now is go back to where we started, and we know that we've already got 2 pi r squared in the bag. That's the curved surface area of the hemisphere. we can now work out the area of this part here, which is just a circle. So the area of the circular base is going to just be pi times the radius squared, and we know the radius is 4, so that's going to be 16 pi, and that's in centimetre squares. And I should have said here, we now know the curved surface area of the top, that's 2 times pi times 4 squared, because we know what r is now, so that's going to be 2 pi times 16, which is 32 pi centimetre squares. So all we have to now know is what the curved surface area of the cylinder is going to be. So if the cylinder was in blue here, so there was the cylinder, and basically if we want to find out the curved surface area of the cylinder, then think about it. We know one unit here, we know it's 10 centimetres high. So if you imagine cutting down the side here, you'd actually make this into, and let me just get a bit more space. If you cut down this green dotted line, you would basically make it out to be a rectangle. The height would be 10, but this distance here would be the circumference of this circle, and the circumference is pi times the diameter, and so that would be pi times 2 of the radii, and we know the radii are 4 each, so the diameter's got to be 8. So we know that the curved surface area here is just 10 lots of 8 pi, which is 80 pi centimetres squares. So just do a last check and see we've got everything we want. Well, let's have a look. We have the circular base here, so there we go, that's 16 pi centimetres squares. We have the curved surface area of the hemisphere, here we are, 32 pi centimetres squares, and now we have all the curved part going all the way around the cylinder, which is 80 pi centimetres squares. So if we add all those together, we have 80 pi plus 16 pi plus 32 pi, which is 80 pi plus 48 pi, which is 128 pi centimetre squares. So if you break that problem down, it's not too bad. And don't forget, when you've got a cylinder, you can just cut down one of the sides and make it into a nice rectangle, not forgetting that this length here would be the circumference. That does trick people out quite a lot. Another thing that catches people out is they sometimes count this area where the hemisphere connected with the cylinder as being a bit of extra surface area. You can't actually see this part here, so don't count it, okay? It says expand 1 plus root 2, so I'm using a grid here, multiplied by 3 minus root 2. Put the plus sign in if it helps. And then let's have a look. 3 times 1 is 3. 3 times root 2 is 3 root 2. 1 times minus root 2 is just one of those, so it's just minus root 2. And then be careful here, a minus times a plus is a minus. And then root 2 times root 2, you can either write root 4 or think in your head root 2 times root 2 is 2 to the half times 2 to the half, which is 2 to the 1, which is just 2. So you could have written just 2 there. So let's see what we've got. We've got 3 for definite. We've got minus 2 for sure. And then we've got 3 of these with one of them taken off, which is just 2 of them. And then 3 minus 2 is 1 plus 2 root 2 is the answer. With this question here, we've got something in the bracket to the power 0, or anything to the power 0 is just 1. And I explained that in a previous video as well, that if you had a squared that's a times a. If you had a to the 1, that's just a. And then if you think about this one, how's this changed? Well, if I had a cubed, that might help you. That's a times a times a. What I'm actually doing to get from here to the next one, I'm just dividing by a. So a to the 0 must be a divided by a, which is just 1. And then a to the minus 1 must be 1 divided by a, and a to the minus 2, and so on. So I just want to reinforce that with you, that 3e to the 0 is just plain old 1. Simplify fully. Well, if we've got 64 x to the 6 all over 25 y squared, and it's all to the power minus a half, the first thing I would do is try and look at what this minus does. This minus tells you to invert everything. So do the reciprocal. So that is what I'm going to do first. So I'm going to make that minus disappear. So I'm going to have to invert this. So I'll have 25 y squared divided by 64 x to the 6 to the power of a half now. Okay, so I've got rid of that minus sign, which just tells you to invert. And then to the power half is the same as square root. So you've got to think to yourself, what times itself gives 25y squared? Well, what times itself gives 25? That's 5. And what times itself gives y squared? Well, that's y. And then just check it. Does 5y times 5y equal 25y squared? Yes, it does. Now, you've got 64 x to the 6. Well, the square root of 64, that's easy enough done. But be careful, what times itself gives x to the 6? Well, if you've got x to the 6 written like this, and they're all timesing, then surely you've got x cubed times x cubed gives x to the 6. So you've got 8x cubed. And that looks good enough to me. Now let's have a look at this question here. Write as a single fraction. Well, this is where students start making a lot of errors, and let's try and avoid those. Let's imagine we had 2/5 take away 1/7, where you try and get these denominators the same by timesing top and bottom here by 7 and top and bottom here by 5, and then you'd have 14/35 take away 5/35. Think of the same principle here. So really, you can times left or right, it doesn't really matter, but I think you're probably better off timesing by the right hand side here. X plus 3, and then x plus 3 here, so that's really timesing by 1. And then here on this side, times by x minus 3, top and bottom. Don't forget the bracket here. And that's the same as timesing by 1 also. So you've got a common denominator of, now some of the students here might notice this is like a plus b times a minus b. So you could say x squared minus 9. But I think most of you would probably stick with x minus 3 times x plus 3. And then multiply these parts out, so you've got 5x plus 15. Now be very careful here. Minus 4x, and then the two minuses here would make the plus. 4 3s are 12. And then keep your denominator here. And then you've got 5x, take away 4x is x, 15 and 12 is 27. Okay, and then think, does anything else cancel? Don't be tempted to cancel one of these off. That's not how this works. That's quite a lot to explain in this video, and I'm not going to attempt to do that, but just leave that be for how it is, and then that should be the answer. Okay, it is the answer. So let's have a look at the next question. Well, in this question it says Paul takes at random 3 of the cards he adds together the three numbers on the cards to get a total. Work out the probability that that t is an odd number. Well, if you have three cards, the only way of getting an odd number, I would say, would be the following. I guess you could have an even, odd, even, odd, then an even, then an even, or even still an even, and an odd. And then, yeah, odd, and odd. So there would be the three you could have, and I guess probability language, you should probably do P of these. But as long as you've listed them. And then you say, right, 8 cards, and then takes 3 of the cards. So don't try thinking that you took 3 at once. Okay, with probability, you've got to kind of imagine it's 1 at a time, and there's not going to be any replacement here. So for the first one here, to get the first even, well, there's 2 even numbers out of how many cards? 8. And then the second card is an odd number, so be very careful now. There's 1, 2, 3, 4, 5, 6 odds, but there's only 7 cards left. Okay? And then taking your next even one, it's got to be 1 less even number because you've already picked one, and then 1 less card. I wouldn't cancel anything down at this moment. Or, so we start all over again, or it could have been an odd one, which was 6 odds out of a total of 8 cards, times by an even, which is 2 out of now 7, times 1 out of 6. Or start again, even, 2 evens out of 8 times 1 even out of 7. There couldn't be another even one because that would be 0 out of 6. So we've got an odd here, thankfully, which is, how many odds are there? 1, 2, 3, 4, 5, 6 out of now 6 cards. Okay, so that would be 6 out of 6. And then lastly, odds. So we've got 6 out of the 8 times 5 out of the 7 times 4 out of the 6. Now, you can cancel these down. If you can try not to, it'd be better because that'll tell you more about what's going on. So I'm sure we can do 2 times 6 times 1, which is 12. Now, if you can just get this denominator right, then it's the same for each time. So 8 times 7, that's 56, times 6. Well, 6 50s are 300, and 6 6s are 36. So it's 336. Then they're all out of 336 now, because there was always going to be 8 cars, then 7, then 6. And then what have we got? 6 times 2, so that's 12. And then 2 times 6, that's 12. So that's looking like they're all 12s, but be careful, because this last one isn't. It's 30 times 4, which is 120. So what have we got? Out of 336, we have 12, 24, 36, and 120, which gives you a total of 156 out of 336. And I'd leave my answer as that, whereas some people would have cancelled these out to begin with, and so on, which I'm not going to do right now. I'm just going to cancel this fraction down, which you don't have to do, there's no point. So 78 out of 168 would then be 39 out of 84, and then I guess 3 goes into 39 13 times, and 3 goes into 84 28 times. So 13 out of 28 if you want, but I think 336 is better because it tells there's 336 possibilities altogether, and you've just got 156 of them. So that's the reason why I don't cancel in probability. Okay, so that's that question done. Now this question is a quality of written communication question again, and it says A is the point with coordinates 1, 3, and B is the coordinates 4, minus 1. And it says the straight line L goes through both A and B. Well, the first thing I would do is to work out what the actual line is, L. So first thing to do is to find out the steepness of it. So that's the change in the y over the change in the x. So what I can do here for you is just go into a little bit more detail, just so you can get a rough idea. You may not have time to do this in the exam, but if you went 1 along and then 1, 2, 3 up, you would have coordinate A, and then if you went 4 along and 1 down, you would have coordinate B. So you can see that the gradient's going downhill to start with, so that's important. So if you look at the difference in the y values here, so I may as well just show you from scratch really. Let's have a look. So if we're going the difference in the y, so my advice is to draw a triangle wherever you can, a right angle triangle here, and then if you join these points up here, A and B, you just got to study that triangle, and basically you'll see that we've gone 1, 2, 3, 4 here, and then we've just gone along, and just make sure you get this right, 1, 2, 3 here. So when you're looking at the gradient, it's always the change in y over the change in x, and I don't know whether any of you have seen delta y over delta x or dy dx as being the gradient. If you haven't seen that, then you're going to have to put a bit more practice into finding the gradients of straight lines. But if you do the difference in the y values, so if you look at the change in the y over the change in the x, you'll get the gradient no matter how you do it. So let's have a look at the first way. So the change in the y we managed to find was 4, and the change in the x was 3. And was the line going uphill or downhill? So if you extend this line here, is it going uphill or downhill? Well, it's going downhill, so it's got a negative gradient. So that's one way of helping you. Another way is if you write the coordinates here on top of each other, and you do the difference between 3 and -1. Now there's two ways of doing that. You can either do 3 take away -1, and then do the same here, 1 take away 4. That will give you 3 add 1 over 1 minus 4, which is -3, and that's again -4/3. If you don't like that, then you can write the coordinates out and do it this way, -1 minus 3 divided by 4 minus 1, and that will give you -4 over 3, which again is -4/3. I like the triangle way. Sometimes you can't do that, obviously, because the coordinates won't fit on the page, but try and get a sense of whether it's going uphill or downhill. And lots of my students in the past have had brilliant ways of doing this by using sequences or just looking at the coordinates and seeing patterns. There's not just one way of doing this, there's plenty of ways. So we know that y equals -4/3 x plus some constant, which is the intercept. Now, there are many ways of doing that. You can read it off the graph if your graph was really accurate. But personally, what I would do is, I would say, use one of the coordinates, which is nice, 1, 3, and that means when x is 1, y is 3. So you just plug that into here. So you get 3 equals -4/3 plus c. Add 4/3 to both sides, and you get 3 plus 4/3 is c. Well, 3 is 9/3, and there you got 4/3 there. So you got c is equal to 13 thirds. Okay, so that's the equation of the line. So that's done. It says, is the line with the equation 2y equals 3x minus 4 perpendicular to the line L? You must show how you got your answer. Well, when I did this question here, I did a little bit more than was necessary, which is absolutely fine because I'm trying to teach you a little bit about straight lines as well. So you would only needed to have gone this far to start with to find its gradient, and then what you'd have to do is compare it. So if you knew the facts about L, and L was such that its gradient was minus 4 thirds, you've now got this equation here, which is 2y equals 3x minus 4. Well, what's the gradient of that? We'll get it in the form y equals mx plus c. So divide both sides by 2. I would have y equals 3 over 2x minus 4. So you've got to find out and see whether it's perpendicular to the line or not. Now, perpendicular means at right angles, and the rule for being perpendicular is that when you times the two gradients together, you will always get -1. Now, I don't have loads of space to show you why that's the case. You can watch a video on straight lines to help you with that. But if you always multiply the two gradients of lines that are at right angles to each other, they're always going to be -1. So let's have a look and see if that's the case. So the gradient of the line L was minus 4 thirds. The gradient of the line we've just found is 3 halves. And although these cancel, I'm left with minus 4 divided by 2, which is -2. So I would say not perpendicular. Another way of working with this question is if you have a gradient of a line that you found, say of L, we had the gradient was minus 4 thirds, then if a line was perpendicular to it, what would you have to times it by to give -1? Well, if a line was going downhill, it would have to go uphill to be at right angles, so it would have to have an opposite of negative, i.e. positive, and then 4 thirds times what gives the 1? Well, it would have to be 3/4. Now, we can see that 3/4 is not what I have here. I had 3 halves. So that's another way you can actually say it would have to have been 3/4 and it wasn't. But personally, I would just times the two gradients together, and if it's not -1, then it's not perpendicular. So that's how I would do that question. Well, for this question, we're looking at how the minimum point here changes. So if I just call that M3 -4, well, first of all here we see y is equal to the function with 3 added on. So what we need to say is, and I'm not going to do a whole video on transformations right now because this video will just take too long. I'm going to say to you, read this as y equals the function, but I'm adding on 3. So y itself is going to be what I started with 3 more. So that's just the y value. So if I write down this coordinate here, 3 minus 4, I've just got to make the y value translate upwards 3 units, parallel to the y-axis. So what would it become here? Well, m dash, let's call it, would be, the x would stay the same, and the minus 4 would go up 3, so that would become -1. So 3, -1. Let's leave part 2 out just for the moment, because that's by far the most difficult to explain and to do. So let's look at this part here. Here, the function y is f of x is exactly the same, but all that's changed is that x has become its opposite, or its negative. So when you look at a graph like so, and it's got x values across here, if you take this x value here at 3, it's just saying that x value has to be its opposite. X becomes negative x. And then what that means is that the y-axis becomes the mirror. So the whole graph will just mirror in the y-axis. Now you probably know a little bit about transformations already. If you don't, I have got a video somewhere, and I'll try and put a link on here at some point, and I might just do a special video on transformations. There are plenty out there already, and I've seen some good ones as well. So I'd say x becomes negative x, so it's not 3, it's going to be negative 3, and the y value stays exactly what it was before. So I would go negative 3, negative 4. Now this is the difficult one here. Now this is going to be a stretch here. Now to explain this one here, I'm just going to do, if I can, without messing this up, let's have a look. Let's see if I can move this. For this question here, this last part which I've left till the very end, I'm probably going to do a bit of an injustice here with the amount of space that I've got, but I'll try and do a little mini lesson here. If you had a function f of x is x minus 1 all squared, well, this would be the same as the function x squared, but move forward 1 parallel to the x-axis. Okay, so it would cut up here somewhere. Now, if I just look at this as an expansion, I'd have x squared minus 2x plus 1. That would be f of x, and this would be the green one here. Okay, and this is y, and this is x. But if I had f of 2x, let's see what happens here. Well, x becomes 2x now, so I'll have 2x squared minus 2 lots of 2x plus 1, and that will give me 4x squared minus 4x plus 1. So, how does that change what's happened in this situation? Well, if we compare this one here, and I'll draw boxes around them, f of 2x and f of x in this case, the intercepts were unchanged, both at 1. But what would the line of symmetry be? Now here's one way of looking at it. The line of symmetry is minus b over 2a. So for the f of x graph, it's going to be minus minus 2, which is 2 over 2a. So the line of symmetry is going to be at x equals 1, just had we had here, x equals 1. But for the f of 2x graph, if we use x is minus b over 2a, we've got minus minus 4, which is 4, over 2 of these, which is 8. We actually get x is a half. So what I'm trying to say to you is here's the new line of symmetry, which I'll put in a different colour. Here's the new line of symmetry, and what it's actually done, it's actually taken an x value that we knew and it's halved it and plotted exactly the same height as it was before. So if you look back at this one here, and the coordinate was m was 3 minus 4, what this f of 2x will actually do is it will take the x value and it will actually halve it, but the value will still be plotted at the same height as it was before. The y value will be completely unchanged. So I'll do a few more of these if I come to do other papers and I see this evil transformation here, which is really hard to explain in such a small amount of space. But basically, you take an x value and you always do the reciprocal. So if you've got f of 3x and you had a point, say Q, which was 5, 8, you would actually take this number 3, you do the reciprocal of 3, which is 1/3, and that's what you would times the x-coordinate by. So your new coordinate would become 5/3, but still plotted at the same height as before, which would be 8. And if I had f of a half x, for example, and I had a coordinate r, which was -2, 3, I would take my x-coordinate here, and I would do the reciprocal of a half, which is 2, and I would multiply it, and I'd get r dash was -4, but the y-coordinate would be unchanged. So where were we? My answer for this very last part will be, I take the x-coordinate, I halve it, and my y value stays exactly the same.